Hi everyone, Connor McDonald here. Let's talk about triggers today. There's a lot of information about triggers out there and they're very cool. You can do a lot of very cool things with triggers. But as a result, often people tend to put them into their application code rather than doing the changes perhaps in another layer like a PL SQL layer or even upstream in the application. Because you can hide stuff away in a trigger that the application is not aware of. That can be both a good thing and perhaps a bad thing if you don't really understand what you're doing. So first of all, let's cover off one thing that we should not be doing triggers for, and that's primary key generation. That's a fixed problem. In Oracle 12 now, you can have a default of next val in a sequence as part of a definition on a table. If you're one of those people that uses, for example, GUIDs, there's a default function sysguid to do that as well. So realistically, I don't think there's a lot of justification now for using triggers just to populate a primary key. I think we can do better than that. This is a different one though. This is about using triggers to implement business logic. Now don't get me wrong, there's nothing wrong with putting business logic in the database. The problem here is if you can code something very simply in a trigger, often that'll give you the false impression that you didn't need to worry about the complexity of implementing business logic wherever it happens to be. Triggers make it so easy to code up that often we get lost in the actual complexity. Let's look at an example. This is motivated by the fact that I saw this on Stack Overflow and realized someone was heading down a very slippery slope. Here's our business requirement. I'm going to start with the familiar example of the employee table and the department table, department being a logical parent to a set of employees. The requirement was each time we update an employee's salary or insert a new employee, what we should do is store a total salary for each department against the department table. The original Stack Overflow solution had the familiar mutating table error, and that makes sense. They updated an employee and then they wanted to query that same employee table when they wanted to update the total salary for that person's department. So someone's first attempt at a solution was obviously never going to work. And then the problematic solutions started rolling in. The first one was, well, you could use an autonomous transaction. That's a disaster. That's data corruption waiting to happen. We'll talk about that perhaps in another video. The other solutions were well intentioned, but didn't take into account some of the complexity that arises when you're dealing with cross-table data consistency. So to solve the mutating table problem, the first attempt was let's use a compound trigger, a really cool set of trigger coding facilities available since 11G. In that way, we could defer applying the changes at the row by row level and do all the work in an after statement trigger. When we look at this code, without going too much into the details, the main problem was it assumes we're only updating a single row. Obviously, a single update statement could actually affect more than one row, and so that solution breaks down. And some people on Stack Overflow pointed this out. So the revised solution was we'll store all the row level changes into a PL SQL table, and then in an after statement trigger, we'll apply all of the outstanding changes. So just in case someone doesn't update that affects multiple rows, what happens is we will now take that into account and hopefully our department salary running total will be correct. Even that solution was incorrect because one of the things it did not do is take into account when someone changes department. What happens when we look at the simple update statement of setting department number to department number plus 10? Simply because we know all the department numbers in our sample data are multiples of 10. We have a problem there because the compound trigger was not taking into account that people were exiting a department, not just entering a department. So now we have a problem of having to manage both the new values and the old values in the trigger, so we can both increment and decrement salaries for the various departments. Now I'm not going to show the code that would solve even that problem, because even that introduces complexity that we're perhaps not aware of. What we're doing now is that every time we touch an employee row, we are locking, because we are updating, the associated department parent row. Now that might be fine, but it also could introduce unknown application impacts that you weren't expecting. What if I'm someone that wants to come along and simply update the department table? I might get a locking problem. Why is that? It never happened before, but now that this trigger on a seemingly unrelated table, the employee table, has been introduced, I might see locking issues that I might never have expected. And let me stress, this locking is required. We simply can't not lock the department table. If we are going to do this total salaries against each row on the department table, we need to serialize at some point, and it has to be on that department table. I'm just saying that there's hidden complexity here that we need to take into account. There could be other impacts as well. What if other parts of the application have a workflow which updates a department row first and then moves on and updates employee rows in the same transaction? Well, now we have an issue because part of the application tackles DML in terms of department first, then employee, and our trigger now tackles rows in terms of employee first, then department. We might start having some deadlock issues in our application simply because this trigger existed. The problem here is not inherently that we used a trigger. The problem here is that a trigger made a solution sound so simple, but its complexity grew and grew and grew. Perhaps a better option would have been to have a materialized view. So we have materialized view logs on the employee table, such that every time we do an update onto the employee, we store the changed row, and then we have an on-commit materialized view refresh. In that way, we are using the materialized view log almost like a queuing system to queue up the list of changes that have occurred to the table, and then at refresh time, we will keep our salaries up to date. We didn't need a trigger, and we solve a lot of those complexity problems. Which is the best way? Well, only the author of this problem can actually tell. My point is, you need to be very careful with triggers. As you code up a trigger, if the answer seems really simple and you're doing cross-table dependencies, please pause, take another look. Make sure you handle multi-user issues. Make sure you understand the locking scenarios. If you can handle all that, then go ahead, use those triggers, but please be careful. See you all soon.